So today's video, we're going to do it a little differently. We're not going to do a specific project. I want to go more into the details and ins and outs of a specific function. That's the UV Wrap and Unwrap. I'll start by showing you how to use the tool in case you haven't used it already and how it works. And then we'll go through some different strategies to help avoid failures. It is a deform tool, so just like any of our other deforms, there are sometimes some issues if your object is over complex or not drawn properly or built properly. It will fall apart as you try to deform it too much. So I'll give you some little bits and tips to help you out with that and avoid those problems. So let's get started first with, I'm just going to pull a ring out of the library here that I did earlier. Simple band. And I'll show you how to unwrap the surface so that we can maybe put some patterns onto it. So you select the ring, and before we can unwrap, unwrapping doesn't unwrap solid objects. We have to unwrap a specific surface. So the first step is to copy the surface from the ring. So I'll use copy faces here in the surface controls. Select which face I want to unwrap and validate that. So now I have a copy of the face here in the tree. Let me just freeze that so you can see it. So that's the surface. I like to hide that surface. I don't need to see it to unwrap it, so I hide it, select it, and then unwrap it. Okay. Now when you unwrap, you get a grid. It's a flattened version of that surface. So it's deforming it, it's flattening it out so that we can place our objects in the flat version and then wrap it back to the 3D version. Okay, so the controls are pretty simple. Most of them, or all of them, are really just about aligning the grid the way we want. That's going to make it more comfortable for you to put stuff into. So the location, or the center, is your standard XYZ transform gizmo. They place it 10 millimeters from the center by default, and that's just so your grid is up here out of the way and it's not right on top of your ring that you're unwrapping or whatever object is centered. Now you can always center your object. Sometimes I like to do that in case I'm going to be centering whatever I put in there. It's much easier if the grid is already centered. But for today I'll leave it at the 10. You can move it around anywhere you want. Okay. The next set of controls are for the rotation of the grid, and that is related to the points that they show you here. There's a little XYZ compass on the corner of the grid, and that relates to where it gets placed on the corner of the wrapped version. So anything I put in this bottom corner is going to start at this corner of the grid and work its way down the other way. So again, that is so it makes it easier for you to align your objects based on how you want them to be rotated when you put them back on. We'll take a look at that a little further when I actually put some stuff in here. So next we have the actual columns and rows of the grid itself. These are just visual, and it's up to you how you want to use them, how many you want. I use it a lot of times if I'm doing a pattern that repeats along the surface, and let's say I have 10 patterns, I'll use 10 rows so that I can use these lines to align my objects to. So again, helpful with patterns, and it's up to you how many you want, depends on what you're doing with it. So you can set them in any amounts you need. So finally we have keep original, like most tools. If you want to keep the original surface after you wrap it, that's fine. And then we have use bounding box of object. Now this one, what you can do is actually select an object. I'll select the ring. It's going to resize the grid to the object's bounding box. So if you imagine a box around this ring, it's going to resize the grid to fit inside that box. Now that's going to cause even more distortion than with just a regular wrap. So typically on a ring like this, I wouldn't use that. It's going to make it even more difficult to align everything to and keep it from overly stretching back to the original grid. So you see the big difference there. So the only time I would use this if I was wrapping to a flat object, a flat surface, I can use the bounding box to align to that surface so I can kind of align directly on the surface instead of having to guess where it's going to go. Not really something I would use. So just to point out what that is in case you were curious. So that's it. We validate and we've got our grid. We're ready to start placing our objects. So I'm going to start with some text, and that'll help me show the rotation on the grid as well. So I'm going to go into a sketch in that same OXY plane that the grid is in. And here's a good place to turn off the sketch grid. So if you have your snap bar up here, you can just quickly turn that off. We have the new grid that we're putting our objects in. We don't need to see the sketch there where everything's on top of each other. Much easier to see if you turn that off temporarily. So I'll just align my text, just start typing it out. Okay, now text, like any other time you're using text, you want to think about the fonts you're using. The more complex the font, the less likely it's going to deform and work with what you're doing with it. It's also probably, if you use too thin or too much of a cursive type font, those things aren't going to show really well after printing and casting anyway. So you want nice, bold, big text whenever possible. So I'm using just an Arial black, nice, bold text. So this should wrap really nicely. You'll have to experiment with other text fonts that you have on your system to see which ones deform and which ones don't. You definitely want to look for errors in the sketch after you type out the text to make sure it actually is a good curve. So look here for the little warning exclamation mark. If you have that, it's definitely not going to turn into a solid unwrap. And then I'm just going to line it using those grid lines, those columns and rows. So I'm just going to use the arrows on my keyboard. You can use the move tool. So we just want to get it centered as much as possible. You can also use your layout tools down here for centering. Remember, if your grid's not centered, you can't just center it to the center of the screen. Otherwise, it'll be down here where the ring is. So keep that in mind. That's another reason I like to move the grid around. But I'll just quickly place it by eye and then validate that and then exit out of here. So when doing text, I'm going to have to extrude the text. I don't want to wrap the text itself because then it won't extrude with caps on it. That will be no good. So we will go ahead and extrude it. Now when you're doing your extrude, you want to think about the placement of the text in the grid in the Z direction as well. So not only is it aligned to the grid in the X and the Y, that's where it's going to end up on the surface, but the depth of my object is going to be based on the Z as well. So if I do it like this with just the default 1 millimeter on top of the surface, on the ring it's just going to be on top of the surface. I'm not going to be able to boolean it. We want the text to sink below the surface a little bit. So I always do both sides and then choose the sweeping distance. Whether you're cutting it out or leaving it on the surface, it doesn't matter, it's going to be the same either way. So let's say I want a 1/4 millimeter depth or on top of the surface, either way. And we validate and we see my text is halfway into the grid. That's how it's going to be on the ring itself too. So keep that in mind. And now the easy part, we put it back onto the ring by selecting the solid object and the grid itself. And we do the opposite of unwrap, and that is the UV wrap. Okay. It's going to place my text. We validate, see if it's going to deform properly. Again, simple blocky text should be no problem. You want to look for letters turning black, disappearing, things like that. You can run your part doctor on it. You're probably going to get a violation of tolerance. Whenever you deform something, those edges have to be moved around. They're going to get out of tolerance a little bit. Remember, a violation of tolerance does not mean there's an error that it's not going to work. It just means that there's a warning. We should probably check the object to make sure it's okay before we start cutting it out. And to do that, I use polygon conversion. Display errors on, correct off, use the same resolution that you export with, and just hit preview. Look for bad edges. They'll have red lines on them. You'll see them almost immediately. If you don't have any, good to go. We'll keep working on this. If not, we may have to think about using some different fonts or changing the size or scaling of the text, playing around with different curves to get this to work. If it's just a couple of letters are bad, I might ungroup those and fix those in the NURBS curves themselves. So we get the idea. Some texts are easier to use than others. I recommend trying to stick to those. Okay, do not validate your polygon conversion. We don't want to actually convert these to polygons. We're just using it to test for errors. Okay, so we see my text based on the orientation I have my ring. It's backwards to the way I want it. So this is where that grid rotation and positioning is important. If I go back to the grid, double click in there to the UV unwrap, we'll just rotate it. So 90 degrees, rotate it that way. That's definitely not what I want. I'll do 180. Now when I go 180, it's rotated down to the bottom side of the ring. So I'll just do negative 10 in the Y to put it back where it was, instead of having to move the letters around. You can obviously go in and rotate and turn the letters upside down. That's extra work when we can just flip the grid over. So 180 looks like the one that I want, and we can tell by here my start point of the grid is now over here in this corner, so that's the way the text is going to align. The E is going to be here instead of the T. So validate, recompute, good to go. Easy fix. Okay, real quick, we also have flipping. So you can rotate and flip the piece if you want. If I go back into the unwrapped grid, down here you have the same normal 90, 180, 270, but they're also flipped. So if I do 180 flipped, you notice that my Z is now pointing down from the original plane that it was drawn on. In the unwrapped version, or the wrapped version on the ring, my Z is still pointing up. So that's going to reverse everything in the Z direction. If I validate to show you what that looks like, my text will be backwards. Okay. Now, when would I use that? I guess if I was doing some molding or something where I wanted things to be in reverse, maybe something like that. Or if I'm fixing a problem, if I drew my text on a plane that was backwards and my text comes in upside down, use the flipping to correct it. But in the default planes, you shouldn't have to worry about that. So I'm going to go ahead and put that back to the regular 180. That's the way I want my text to flow. Everything looks good. Show the ring. I'll hide this stuff. And there we see where we have our text in the surface. We know exactly how deep it is because that's the sweeping amount. I did 0.25, so it's 0.25 above and below the surface. So again, like I said, it doesn't matter if I'm cutting it out by subtracting or if I'm doing addition to put it on top of the surface. I know how much it is either way. And I think I select that in the wrong order. Try that again. There we go. So now they're cut out 0.25 millimeters deep. So next I want to talk about how we can set up our sweeps using properly drawn profiles so we can control which surfaces we can wrap and unwrap. So you saw on that last ring that I can only choose half the surface, and it was a square profile, so it's pretty simple to select the outside surface. But other times we can't really choose the surface we want if we don't plan ahead for that. So I'm going to start by just setting up a ring size and then draw some profiles. I'll start with how I would normally draw a profile if I wasn't worried about surfaces and edges. I would just start with a symmetrical curve and do something like that. Okay, so when I sweep that, excuse me, let me do a sweeping wizard here, and we'll add our section. Oops, not the library. Okay. So if I sweep that section, we'll see when I go to copy my faces, we have this odd split on the face because of the way I drew it. This is a symmetrical curve, so I drew it starting over here on the corner. That's where the start point of my surface is as well. So I've got a start point there, and then it also splits that surface in half automatically. So we get an opposite corner. Okay, so to make that a little more control, so I have just the top surface here. If we draw our profiles using multiple curves instead of just one curve that's symmetrical. So I'll still use the symmetrical curve, but I'm going to leave it open, and starting with the outside point, we'll draw just the top shape that I want. That'll be the surface that I unwrap. Now I still need a full profile, so I'll use another symmetrical curve, turn off close curve, connect the dots to start it off, and then draw in the rest of my shape. So again, whatever shape profile you want, just think about where you want the splits in the surface to be, where you split the two curves. Okay, we'll join it back together. Even joined, we still have those 2 points that are sharp. That'll cause the surface splits that we want. So I'll go back and replace this section here using this one. And we'll see now that when I copy my face, I have just the outside surface where the splits were. Okay, now the other thing is we see that it still splits my surface based on the path in half as well. So I've got split here at the start point of my ring size, and at the bottom where it splits it in half. So you can fix that as well. In version 8, they added in all of our sweeping tools, you should see this button here called No Cutting Face. So I'm going to turn that on, redo the sweep, and you'll see without the cutting face, I get a single surface all the way around the ring. So now I can unwrap it as one single surface. Okay. If you watch my surface control videos, it shows you some tricks on how you can take two surfaces and put them back into one surface. So you might do it that way too, but it's best to start off with a single surface because you can only wrap one surface at a time. Okay. So we'll validate that. And now I have my copy surface. Again, it's inside the other surface, and I don't really need to see it, so I'll hide it and unwrap it. Okay, so there's my single long surface the way I want it. So the next thing I want to talk about is when placing objects into this grid. If I'm just going to place a bunch of solid objects and then wrap them, think about keeping them separate. So let's say I'm just going to do a simple pattern using some spheres. I'm going to lay out, flip over here, I'm going to lay out a little tiny sphere like so, and then I'll just duplicate it using a matrix copy. I'll do 4 in either direction and adjust the spacing, something like that. So that's the pattern I want. And then I'm going to just repeat this pattern again using another matrix copy, this time only going the U direction. And we'll do about 11 and then adjust the spacing. So something like that. So that's my pattern. So a lot of times you'll set up your pattern. Like I said, this is a very simple example, but you may have a complex pattern that's a bunch of different shapes and parts and things thrown into the grid. You'll be tempted to group them or Boolean them all into one object. These are already grouped. It's much better to select the entire group and the grid and wrap them as a group as opposed to Boolean adding them together first. Because this is going to deform each piece individually instead of a more complex Boolean together shape. So something to think about with your patterns and designs. The more you can simplify them into smaller pieces that aren't Boolean attached, the more success you'll have getting them to wrap properly. Because we can always Boolean them together after you get them onto the ring. Okay, now I want to talk about curves themselves and some things to know about curves to help you get better shapes that will deform properly. So I have a simple image in plane here just with some simple leaf patterns just to give me something to trace around. And let's say these are the shapes that I want to deform to my ring. So some things to keep in mind when drawing them. You're going to be tempted, especially like this leaf. I'm going to want to draw it using several NURBS curves like so. Okay. Now what I've done here, let me go ahead and connect those together. I've created a curve that now has 3 extra edges that I don't really need. We have the sharp point here at the tip where the 2 curves touch, and 1 in each corner where those 2 curves touch. So this is what we call a non-periodic curve. If I run my part doctor on this, I'm sorry, my sketch doctor, not the part doctor, we see it's closed. It's a periodic is 0, meaning no, it's not periodic. Basically what mathematicians call a periodic curve is a curve with no sharp points or kinks in it. So this would be periodic. This the type of curve that will cause, nice solids with sharp edges, but the more edges you have, the more complex or harder it is to deform those shapes. So to avoid those edges, as I'm drawing the curve, if I could think of doing it as one single curve, when I get to the corners, just draw 3 points closer together. Still create corners, but they don't have to be sharp. So when doing extrusions and deforming them, I like to avoid sharp edges. Notice that I closed it off smoothly, so we don't get the sharp point here at the start point as well. It should be nice and smooth. Okay, so if I run the Park Doctor here, we see we get, I'm sorry, again, the Sketch Doctor, it is periodic. So less edges. Now I only have 2 edges on this extrusion when I extrude it. The top and bottom of the leaf where it caps off, none going around the contour of the leaf. All right, so now sometimes you have a more complex shape and it's easier to draw it with multiple curves instead of trying to trace the entire shape with one curve. You can still do so, and I'll show you how to turn a non-periodic curve into a periodic curve. So I'll draw this out just roughly using several curves. Like I said, sometimes it's just easier that way instead of having to think of it as one smooth curve. And again, I'm being extra sloppy for time's sake in the video. And so I'll cap it off with just a straight line. So I've purposely created this as a non-periodic curve, a sharp pointed curve. Join this together. So a quick, easy way to fix that, instead of going and deleting all the sharp points or redrawing it as one curve, take your multiple curve shape, highlight it, and then we'll just rebuild it. Rebuilding a curve, let's say it's got 37, I'm going to change it to 39. Just give it a couple extra points. Maybe a few more. You want to keep the shape as much as possible, especially down here around the corners. When you rebuild a curve, it's going to take care of most of your sharp points for you. It's going to leave one at wherever it decides to place the starting point. Okay, so, but see it smoothed out all the other ones. So it is still non-periodic. I'm going to delete the start point or the sharp point, which is going to cause a little bit of a gap here. Come over here and just close it smoothly. That'll fix the start point as well, nice and smooth. We can start using multiple curves to create the shape and still avoid those sharp edges or creating a non-periodic curve. Okay, so there's some tips with NURBS curves, drawing those. Like I said, these curves without the extra edges are less complex than the ones that have multiple edges. These should deform much easier. I'm just going to do a simple bidirectional bend and show you that these will deform pretty quickly. So try that out, test out different curves to kind of see the difference between the two. But like I said, if you just keep that rule in mind, avoid sharp points when you're doing extrusions and deforming them, you should be good to go. Okay, next up we have one more thing, again with sketching patterns and things like that. A lot of times you're going to want to do some nice patterns and a nice pierced type pattern. I'm going to go ahead and sketch out, we'll do a little rectangle here and just make it nice and even, 30 by 10, centered. Okay, and let's do a nice little polygon, got a 3-sided. Do a equilateral triangle and place it over here. And I really like the linear duplication for doing these patterns. So we'll do that and that. And just going to group these together so that I can mirror it on the OXZ. And then take this group like so, and then delete the extra 2 after I ungroup it. So something like that. Again, not a video on how to make patterns, but there's a little fun little quick trick for you. So again, I'm going to group these all into one so it makes it easier to select later. Nice thing about grouping is we can always ungroup them if needed. Okay, so again, you're going to be tempted to create one extrusion from this. Okay, this is a much more complex shape, solid, than how I'm going to show you an easier trick to do it. So we've got way more edges that could cause problems once we start bending them and deforming them, especially a round surface with 2 directions, a U and a V. So to make this simpler, I'm going to extrude just the box. I'm going to do 0.5 millimeter on both sides. And then I'm going to select that group of triangles and do it as 2 separate pieces so that I can later cut these out. So again, I'm not going to cut them now. If I select the 2 groups and do my wrap, or I'll just do a simple deform to show you here, I can deform it as a group again. Much simpler than if I did it all as one complex object. And then I'll just filter the rectangular piece, creating a subgroup, and then do the Boolean after I've deformed. Should Boolean really quickly. We've got our pierced out patterns like so. So next I want to talk about surfaces. You don't have to copy the face to get the surface that you want to unwrap. You can make the surface in any way using your surface tools. If you want to learn a little more about surfaces, I have that surface video from last month. You can check that out. Real quick, I wanted to give you another new way to do surfaces for something to unwrap. And that is in surface controls, we have project surface and angular sector. We're going to talk about angular sector. This was the easiest one to use. If you select a ring, such as this one, it was built on a ring size builder, and click on create a surface with angular sector, we get the angular sector tool, and you can set up how much of an angle you want the surface. So that would be the length of the surface. And also in the settings, you can set the total angle, reference angle. You can do negative if you want the opposite. The width mode can be automatic, or you can set the width of your surface manually. So I'll do a 4 millimeter. It's a 5 millimeter wide band. You can also wrap inside. So if you want your surface to be on the inside of the ring instead of the outside, so perhaps you're putting your name or logo or gold mark on the inside of your ring, you can use this for that. And that's pretty much it. When you validate, you'll get a surface onto the surface of your ring like so. I'll hide the ring or freeze it so you can see. So it's just creating this little square surface based on the angular zone and the width that you set. So perfect for unwrapping. Like so. Okay, so keep that in mind. You don't have to always copy the face to get your surface. You can create surfaces as well. And finally, a little bit for you 3Shaper users. If you have 3Shaper, the nice thing about using 3Shaper objects for your UV wraps and unwraps and wraps, shaper objects are meshes. They deform really well. So as long as your shaper object is clean and doesn't have holes and problems with it, you can really stretch it and deform it to any surface. So I'll show you a cool little trick with this simple band here. I'm going to copy my face. I have a simple single face around the outside of the ring here set up. And I will hide and then select that face and unwrap it. Okay. So here's an example of when I would actually want to use the bounding box of the object. So that's going to scale my unwrap to the bounding box. So I'm going to build my pattern inside the scaled version. That way when it goes back to the surface of the ring, it stretches into a cool pattern. So we'll see that here in a second. So I've already set up my pattern. It's just a shaper object, a little box with some extrusions to create holes in it. Very simple pattern, but and then I repeated it using matrix copy, lining it up perfectly to my grid. So select the matrix copy, the unwrap, we'll wrap it back up, and we get this really cool stretched out version of it, wrapping to the correct size of the ring. And validate that for you. Really great way to work on your objects is using 3Shaper. You can really deform really complex shapes much easier than you can with models with edges and surfaces and NURBS models. So there you go. Hopefully you've enjoyed this video. You learned a lot more about UV Wrap and Unwrap. And we'll see you next time in the Members Care videos.